You've got the fundamentals down: variables, loops, functions, basic error handling. Level 2 is where Python starts to feel like the language professionals actually use every day. In this video we'll cover 4 lessons back to back: object-oriented programming, comprehensions and generators, functional programming patterns, and building bulletproof code with custom exceptions and context managers. Object-oriented programming is about bundling data and the behavior that acts on it into one unit, a class. Let's start with the basics: defining a class and creating instances from it. Init is the constructor Python calls it automatically whenever you create a new instance, and self always refers to the specific object being built. Note a species lives on the class itself, so every dog shares it, while name and age are unique to each instance you create. Inheritance lets a subclass reuse and extend a parent's behavior. Cat and cow both inherit introduce from animal, but each provides its own speak method. Loop over a mix of animals and you get different output from identical code. That's polymorphism in action, and it's why super lets a subclass reuse the parent's own init instead of duplicating it. Dunder methods, the ones with double underscores, are how your objects plug into Python's built-in syntax. Add representing and print shows something readable. Add eq and you can compare two vectors with equals equals. Add and the plus operator works on your own objects too. The property decorator lets a method behave like a plain attribute from the outside. Here, setting radius actually runs through a setter that validates the value, so you can't accidentally create a circle with a negative radius. The object protects its own invariance. Class methods and static methods live on the class rather than an instance. A class method like Margarita works as an alternate constructor, building a pizza in one call, while a static method like slice_count doesn't need self or CLS at all. It's just organized under the class because it's related. That covers the core of OOP classes: inheritance, dunder methods, and properties. Next, we'll look at writing data processing code that's shorter and more memory efficient, starting with comprehensions. Comprehensions let you build a list, dict, or set in a single readable line instead of a multi-line loop. Generators take that same idea but produce values lazily, one at a time, which matters a lot once your data gets large. The shape is expression for item in iterable, with an optional if clause at the end for filtering. You can even fold in a conditional expression, like labeling each number as even or odd, all inside the same line that builds the list. Nested comprehensions read left to right, the same order you'd write the equivalent nested for loops. Flattening a matrix into one list, or transposing rows into columns, both collapse down to a single expression once you get comfortable with the pattern. Swap the square brackets for parentheses and a list comprehension becomes a generator expression. It builds nothing up front. Calling next pulls one value at a time, computed only when you ask for it, and summing a generator directly means you never hold the full list in memory at all. Any function containing yield becomes a generator function. Calling countdown doesn't run the body immediately. It hands back a generator object that pauses at each yield and resumes exactly there the next time you ask it for a value. The same pattern powers infinite sequences, like generating Fibonacci numbers forever, safely, because nothing forces it to finish. Comprehensions and generators are about expressing data transformations concisely. Next, we'll treat functions themselves as data, passing them around, combining them, and wrapping them with decorators. In Python, a function is just another value. You can assign it to a variable, store it in a list, or pass it into another function, and that opens the door to a whole different style of writing code. Here, greeting is set to the shout function itself, no parentheses, so calling greeting later calls shout. Once functions are values, you can put several of them in a list and loop over that list, calling each one in turn. Lambda creates a small, single expression function inline, most often as a key argument for sorting. Sorting a list of people by age becomes one line, though if the logic gets more complex than a single expression, a regular def function is easier to read and debug. Map applies a function to every element of an iterable and returns the transformed results here, adding tax to every price in a list. It's worth knowing map exists, because you'll see it in older code, but a list comprehension usually reads more clearly for the same job. Filter keeps only the elements where a function returns true short words under a certain length, in this case. Just like map, filter has a comprehension equivalent using an if clause, and most Python-style guides lean toward the comprehension for readability. Reduce folds an entire sequence down into one value by repeatedly applying a function to an accumulator and the next item. It lives in functools rather than the built-ins, because for simple cases like summing a list, Python's own sum function is clearer and does the same job. Functions as values, plus map, filter, and reduce, give you a functional toolkit for transforming data. Now let's make sure your code fails safely, with custom exceptions and context managers that guarantee cleanup. Error handling gets a lot more powerful once you write your own exception types and control exactly what cleanup happens when something goes wrong. This lesson covers both halves of that story. A custom exception is just a class that inherits from exception. Insufficient funds error carries a clear name and a specific message, so when you catch it, you immediately know what happened, far more useful than catching a generic value error and guessing. Group related errors under one base class, like app error here, and callers can catch broadly with app error or narrowly with validation error and not found error, depending on what they actually need to handle differently. When you catch a low-level error, you can raise a more meaningful one in its place with raise from, keeping the original exception attached as the cause. Here, a missing config file becomes an app error, but the original file not found error is still there on cause for debugging. You don't lose any information by translating the error. The with statement guarantees a cleanup step runs when a block ends, even if an exception happens inside it. That's why you've been using it for files all along. Any object with enter and exit methods can work with this timer class starts a clock on enter and prints the elapsed time on exit, no matter how the block finishes. Writing a full class for a simple context manager is often more ceremony than you need. The context manager decorator turns a generator function into one instead. Everything before yield runs as setup, everything after, wrapped in a finally block, runs as guaranteed cleanup. Custom exceptions give your errors meaning, and context managers guarantee your cleanup code runs no matter what. Put together with the last 3 lessons, that's a real intermediate Python toolkit. That's 4 lessons from level 2 of the Python mastery path: object-oriented programming, comprehensions and generators, functional programming, and custom exceptions with context managers. Full write-ups and runnable code for every lesson are linked below. Go build something with them.